theoretical approach. You cannot use those things in every patient. Every patient is different, how they kind of elicit this adverse events. So that's why we don't use the scales in practical approach, but the concepts underlying that we use. Like for example, this is WHO scale. In WHO scale, the grading goes, or you can kind of go from this is related, this is not related. So this drug is certainly related, this adverse event is certainly related to the drug. And then as you keep going down the scale, you are kind of removing one of the points to kind of downgrade it to from certain to probable, next to possible, unlikely, unclassified, unaccessible. So unlikely is pretty much not related. So to make things easier, to make your life easier in pharmacovigilance, when you go to most of the companies, they will not have all this gradings. They'll just make it binary. It's black and white, related, not related. So they make it, is the drug causing the adverse event? Is the drug not causing the adverse event? So when you go into WHO scale, this kind of hits you with what you already know. Like for example, let us say this. If you say it is certain, it should not be explained by any other etiology. This adverse event should not be caused by any past medical history of the patient. It should not be caused by any concomitant drugs, drug to drug interactions, food to drug interactions. Nothing should explain the occurrence of this adverse event. That's number one, which we already covered. The second thing is there should be a time plausibility, time relationship with the drug. This is where the bell-shaped curve comes into you should come into your realm of thought process. So you take the drug, the concentration goes up, it is metabolized in the body, and then the concentration drops down. So this whole bell-shaped curve is the concentration of the drug, the time the body takes to take the concentration to the maximum therapeutic dose, MTD, and then it drops down to zero. This is the half-life of the drug. So any adverse event that happens in this half-life of the drug, when the drug stays in the body, is plausibly related, because the drug is in the body and the body has experienced an adverse event during the same time. So there is a time relationship with the drug. Let us say, for example, your drug stays in the human system for, let us say, 24 hours. I'm just giving an example. So let's say the patient take the drug at 6 p.m. It will stay in the body until 6 p.m. next day. The concentration will go to zero only at next day 6 p.m. So your adverse event of fever and vomiting, which is caused at 9 p.m., maybe it is plausibly related, time related, temporally related. Time, temporal is the same. Plausibility is causality. So this time or temporal relationship is the most strongest causality factor. So many times you will see in the causality assessments, it is temporally associated. It's temporally associated. You will see this word a lot. What do that temporal association means is this adverse event happened within the half-life of the drug. This is important in oncology, in cancer drugs, because you're always giving cycles of chemotherapy. So let us say you're giving a cycle of chemotherapy that stays within the body for like 10 to 15 days, and then you give the next cycle. So any adverse event that happens within the 10 to 15 days of which is the half-life of the drug, you can say that until unless there are